guys, what we are going to have a discussion is we will take it forward the hypothesis testing to a separate, different level. Okay, hypothesis testing, what we have studied only one mean difference, isn't it? One mean statistics. What is one mean statistics? Can somebody explain it?
The group of data which are having that is the data which is not grouped together, and we are not using cumulative frequency over there. That is called, I think, single mean.
Okay. Okay, let's understand hypothesis testing. And till now, we have only taken one population, and from it is majorly on one population data set, isn't it? So, what are the examples we have taken? Let's take population mean against some value, isn't it? So we were trying to find out whether the population mean is greater than or equal to or less than or equal to with some business value, right? Let's say I have two population, then the first approach is not going to work, right? Let's take example, something like when we apply for any medicine, right? Suppose you have a new drug is getting introduced to the market, and you try to evaluate whether the drug application have a significant implication towards the recovery of the disease, right? So what we generally do, we take the population and the recovery mean before and after the application of the medicine. Okay, then if there is a significant difference between the recovery average recovery with application of medicine and without application of medicine, and then we can say the efficacy of medicine is significant, isn't it? How does now new drugs are validated? So they generally go for hypothesis testing, and then based on the hypothesis testing they evaluate whether we should recommend this medicine for a specific disease or not. Are you getting it?
Yes.
Yeah. So it's different types, right? Let's say okay, when we go to hypothesis testing, we can have application on any sort of problem. Okay, so how I can segregate this problem? I can have one population, right? I can have one population. Okay. Okay. Even I can have hypothesis testing on two populations. Okay. Similarly, again, I can have for multiple population also, right? So what we can do is I can limit the discussion to two populations, but in the similar way you can apply for the multiple population also. So when we consider is one population, let's have what kind of examples I can say. Example one. When we try to apply for any business analytics problem related to retail market or banking domain or any of the industry, and we try to find out um, whether the decision is around a single mean or not. Let's say um, no, we have seen like in the retail market, if the gross no, purchase is more than $120, then I will try to introduce a some kind of benefit to my customers. Or you can think about something like the customers or my electronic consumers, they will be buying my product if the price is below below some range, right? So these sort of business problems so basically talks about a single population and a single mean, okay, with some threshold value which actually makes a decision whether you will take some corrective actions against your your follower or not, okay, follower in the sense status quo, okay. But when we try to talk about two populations, what is two populations? Like let's say when we talk about two population or multiple populations, we can also have something like independent and dependent populations. Let's say what is independent and dependent population is. So I have these populations are dependent or it can have independent. Okay, so what is dependent and independent populations? Let's say.
Lakshmi, is your the screen is lagging? Sorry.
Sorry?
I think your screen was lagging for now. It's fine. I was not able to see dependent, independent. Now I can see. Please continue.
Now you can see it, right?
Yeah. Now I can see.
Okay. So you see here it was talking about one population, but when you take multiple populations, then these populations can be of dependent type or it can be independent type. Okay. So how you will see, how you will validate whether they are dependent or independent? So you have to do, you have to validate the assumptions. So let's say here I take population 1, okay, so P1 and P2, okay. Now you have to validate whether this P1 P2 both are dependent to each other. Similarly here also you have to make sure that P1 and P2 they are independent to each other. So dependency you have to validate by means of statistical techniques like collinearity. Okay, if P1 and P2 are independent, then you will be finding there is no correlation between P1 and P2. But if you take a hypothesis testing for the dependent populations, you have to ensure that P1 and P2 are correlated. Okay, so let's take an example of a dependent population. Okay, example. Okay, example is like something is you take the same population. Okay, you take the like you want to introduce a drugs. Okay, not a drugs. Let's say you want to introduce a something like dieting course. Okay, so for the same population, you take the average weight of the population before introducing the diet, okay, and after the introduction of the diet. Okay, so you will say that the impact of diet course what you have to introduce to the population have a significant impact on the weight reduction or not, right? So, and you will be setting up the hypothesis testing. How you will do that? It is the same population, isn't it? The population before diet control and after diet control, the same population. Okay, but the population, the variance and mean might be changing. Okay, so it become a two different populations with a different mean and different variance. Now you are trying to say that both the populations are having the similar average weight. Okay, so in this case, you will setting up a two population hypothesis testing for dependent populations. Okay, okay. So what is my null hypothesis here? Again, always you will be having null hypothesis, and then you will be having alternate hypothesis. Right. So null hypothesis says yes. Null hypothesis says yeah. Null hypothesis says mu1 equal to mu2. Okay. An alternate hypothesis says mu1 not equal to mu2. Is it clear? Are you guys able to make any sense out of it? What is mu1? Okay. What is mu2? Mu1 is the average weight of the population before treatment. Before treatment in this case, before diet control. Okay, and mu2 is the average weight of the population after diet control. Is it clear? Hello.
Yeah, Lakshmi.
Understood, Lakshmi. Yeah, Lakshmi. Yeah, Lakshmi.
Yeah, Lakshmi. Understood.
So, okay. So what we are trying to do is now I want to say that the diet control which I have introduced, it have a significant impact on weight reduction, and I can use that statement and try to reach out to the bigger population. I mean, try to reach out to my customers, and this is what my number which it can reduce the weight is, right? So now mu1 you got something, whatever you can say. So how we can say mu1 and mu2 is mu1 and mu2 is coming from the population. So what I will be doing is I will be always trying to get some samples, isn't it? mu1. Okay, let me pull this one. So wait. Before okay, control, and this is after. Okay. Now, definitely mu1, mu2 is population parameters. You will never be getting it. What you will be doing is you have to start getting the sample. So for the same population, you will collect the sample before direct control. So when you collect the sample, what you will be getting? You will be getting sample mean, right? Sample size, then sample standard deviation, isn't it? Similarly, then again you can collect samples, collect sample after death control, same sample mean, sample size, and sample ST. So after you get this data, what I'm trying to say is I'm going to set up the hypothesis testing. So my hypothesis testing is null hypothesis mu1 equal to mu2 and alternate hypothesis mu1 is not equal to mu2. So I can write this in a different way. What I can write is mu1, okay, minus mu2, okay, 0. This is what we need, right? Isn't it? Similarly, mu1 minus mu2 not equal to 0. Isn't it? True, right? So what you're going to do is now you got the sample, you got the samples, you got the sample size, you got the sample SD, similar for before and after. Okay, so my hypothesis testing is mu1 minus mu2 equal to 0 is my null hypothesis. Mu1 minus the mu2 not equal to 0 is my alternate hypothesis. Okay, so what I'm going to do now is I will have the assumptions. The assumption says, with the assumptions, okay, so the assumption says the sampling distribution follows a normal distribution. Okay, so the difference of the means, right? The difference of means of two dependent population follow a normal distribution. Okay, so follow a normal distribution in the sense what it's saying the difference of you got a S1. Sorry, it will be okay. So x1 bar and this is x2 bar. Okay, so you got one sample, right? One sample, and you got x1 bar minus x2 bar. This is one sample you have taken. Okay, so the sample, the mean difference of two samples follows a normal distribution. Again, you can do one thing is you can again use the same central limit theorem. Okay. Okay. So this x1 bar minus x2 bar is a sample collected for this sampling distribution Okay, and the mu will be, the mean will be, mu will be 0, and your standard deviation will be, okay, s over root n. Right. Now what I'm going to do is I'm going to set up the hypothesis testing. So in this hypothesis testing, when you collected one sample, okay, let's say I have a confidence level of 95, so I can say 95 confidence level, okay, or you can say critical error. Critical error is how much? 5%. Okay, so with 5% alpha critical or confidence level of 95%, now you want to set up the hypothesis testing. So what we need to do, we have to see whether I can stay with my null hypothesis. Null hypothesis is nothing but mu1 is equal to mu2, or mu1 minus mu2 equal to 0, or I can reject my null hypothesis due to alternate hypothesis when mu1 minus mu2 is not equal to 0. So what I need to do is I will get the t value. Okay, so this t value will be what? So the t value will be what? What will be my t value here? Can anybody say that? For two sample, how to get the t value? Okay, let me put the t value for this. So if anybody have this book, then I will tell you the page number. You can directly put this one. The t value will be, well, let me play this one. Okay, x minus x1 minus x2, okay, minus mu1 minus mu2, okay, root of, okay, x1 by n1, x2 by n2, sorry, not x1, x2, this will be s1 s1 s2, okay, this is nothing but t value, okay, got it. So what it is saying is, the t value will be x1 minus x2 minus mu1 minus mu2 divided by root over of s1 s2 by n1 n2. Okay, that's how you will get the t value. Now just a second, let me see. If you don't have, give me a second, I'll just confirm back from. If you have any questions over here, I will try to answer it. Hmm. Okay. Yeah, there is a correction. Okay. Yeah. This is for the pool variation. Sorry. This is for the pool variation when uh, two populations are not independent. I mean, sorry, the two populations are independent. Population are independent. And population when they are dependent, it will be okay. It will be d1 minus mu of the t s of d root over n. Okay, this was the t. Okay, so what it is saying is that if your population are independent, then you follow the t not t value is x1 minus x2 minus mu1 minus mu2 root over of s1 s2 by n1 n2. Okay, but when the population are dependent, you have to get like the d minus mu d divided over s of d root over n. So d is nothing but difference of means, difference of sample means, which we got x1 bar minus x2 bar. Okay, and mu of d is nothing but the population difference. Okay, the population difference means mu1 minus mu2. Okay, so what is S of D? S of D is means the standard deviation of your sample means. Okay, and N is your size, sample size. Okay, now so this we can get it from our sample data, right? We can get the sample data. Now I have set up a confidence level of 95%. So now when I have set up the confidence level of 95%, what I can do, this is two-sided test, isn't it? It's not one two-tail test. So 2.5% from left and 2.5% from the right. Okay, right and left. So 97.5% and here 2.5%. So what I can get is I can get the t value. Okay, get the t value for for your what is degrees of freedom. So you got a sample size minus 1, t value, sample size minus 1. Now you got the t value. Now you got the t value from here. If your t value from the sampling distribution, what you're getting is bigger than the t critical value for 97.5 and less than from 2.5, then what you need to do is what do you need to do? You have to reject your null hypothesis, isn't it? If your t value is less than 97.5 and t value is greater than 2.5, then you have to stay with the null hypothesis. So to stay with the null hypothesis means your hypothesis says there is no significant difference in weight reduction after your diet control. So it means that the diet control is not working. Okay, if your diet control is working, then the t value which you got it from the sampling distribution should be much more higher than the t critical value of 97.5 or T critical value or minus 2.5. Okay, so in this case, if your diet control is positively working or negatively working, it will give us the value. Okay, if you want to make it mu1 minus mu2 is the 0 and against mu1 minus mu2 greater than or equal to 0. So greater than or less than equal to 0. Okay, in this case, you can get the values and apply your hypothesis. So is it making sense? You guys are having any difficulties understanding this concept? Sorry.
It's making sense, but my question is there a situation where we need to use Z values, or is it always we need to use T values for this two populations?
Come back again. I could not hear. A lot of background noise was there.
My question was, for two populations, do we always need to use T values, or is there a situation where we can use Z value?
This is a T distribution, T test. You cannot use Z value here. You have to go with the T value, T statistics. Because the difference of two population means follow a T distribution, not a Z distribution.
Okay.
Okay. So you have to get the T value by providing your degrees of freedom. Okay. So this statistics is called a paired paired t test. Okay, this paired t test is basically used when you try to see now is there any significant difference between two population means where the populations are dependent to each other. Okay, and predominantly you will be finding such applications when before and after the introduction of some treatment. Okay, before and after introduction of treatment, in the sense the treatment could be a medical treatment, it could be introduction of some kind of no business strategy decisions, like suppose in the retail market you wanted to introduce a coupon system. Okay, so what you will be trying to find out is whether there is a significant change in revenue because of the introduction of coupon system or not, right, for the same population. Similarly, in the in um, in medical domain, when you introduce a new drug, whether there is a significant improvement to curing the disease or not. Okay, and in the banking domain also you can introduce and see whether by introducing the calls, I mean the service, I mean customer service with some sort of like um, soft spoken approach or any kind of something like you have introduced 24 by 7 service. Okay, so you will be trying to find out whether the customers are really happier compared to before 9 to 7 service or not. So here what you are retaining is you're retaining the population, and these populations are completely dependent, right? But only thing is there is a treatment effect. So the treatment effect is significant or not, you can set up a paired t-test hypothesis and you can evaluate it, right? So yeah, having said that, most of the research institutes generally they go with the paired t-test. It's not like it is only limited to retail market or something. You can, I mean, in this real-time scenarios somewhere it can be ignored, but most of the time before going for some sort of further analysis, they ensure that it have a significant impact because of the treatment. Okay, and then they proceed for the next level of investigation. Okay, just like hypothesis testing with one mean, we also have a hypothesis testing for two means. Okay, here this is for the dependent population. There are other hypothesis testing which is done on the independent populations. Okay, so we can talk about independent populations, but just wanted to know if you guys are comfortable with uh, paid test. I can give some examples. You can try out now so that the concept will be very much clear. Okay. So what I'm going to do is let me create a new data set. And you guys can work out on this. Okay, there is an example here. What it is saying is, let's say a bookstore. He wanted to buy books from. He have a two choice. He can order the books from the no a supermarket, or he can order these books from online stores. Now he wanted to find out, is there any savings he is doing by ordering these books from online store or not? Okay, so if there is a real saving he is doing, then it makes sense to order these books from online store, right? So how I can say this hypothesis testing? Hmm? Say these are the books. Okay, let's say I just put it the book numbers like that. These are the book names. Okay, or say book one. Okay, now say he is ordering from a bookstore, and also he is ordering from a online. Okay, now I'll have a price variation, isn't it? Okay, so let me put this price 200 and 304. Okay, give me a second. 179, 72, 277, 7, 5, 47, 06, 55, 4, 50, 5, 0, 34, 172. Okay, so online, this is the same books, 121, 235, 107, 59, 46, 63, 32, 65, 37, 02, and 44, 70. 128.08. Okay, so this is what the data is. Let's say I have ordered these books from bookstore and online. Now I wanted to find out, I'm really making a significant amount of saving when I order it from the online store. Okay, so if that is the case, then what I'll do is next time when I make any order, then I will straight away go to place my orders in the online store rather than going back to bookstore. Right. So let's set up this hypothesis testing and give me your results. Okay, you do one thing. We can set up the hypothesis testing in your desktop and show me the approach how you try. Okay, Aril, Sunil, and Vinod. Okay, where is Sasi? He have left it. Is it? Okay.
Lakshmi, so we need to set up hypothesis testing. I mean, we need to solve this distribution or something.
Set up what is null hypothesis, what is alternate hypothesis, and then you tell me what should I do, whether the online store is making savings or not. What is my null hypothesis? What is alternate hypothesis? First of all, you do one thing. You also need to ensure that the normality test is working, because since um, we see that the sample data also should follow. I mean, the sampling distribution also should be normally distributed. Null hypothesis difference. I mean, just set up the null hypothesis. Bookstore, you just you maintain that equal to as null hypothesis and not equal to on the, yeah, that's fine. Yeah, that's less than equal to online and greater than equal to bookstore. Once again, bookstore less than and bookstore greater than online. Fine, fine. Yes, yes, yes. Right. let's do one thing. You do it on your desktop. Put the content, how you're approaching, what is your null hypothesis, what is alternate hypothesis, and then get those t values. Okay. Also one more thing is you have to ensure that the sample mean differences should follow a normal distribution. Okay. You uh, plot it the box plot and histogram and see whether it looks like normally distributed or not. Okay, if it is skewed, it means that it may not work, right? So take the sample data and plot it as plot a box plot and plot a histogram and see where the median is. Okay, does it look like skewed? Okay, um, and then know uh, perform the hypothesis testing. Okay.
But can you send this data to us? Like ping it in the chat box or put in Google Drive or something? Google Drive type.
So you need to plot box plot and your frequency distribution plot. Okay. Um, give us decision whether is it a normally distributed or not. Okay. So there is also a function called summarize. The summarize will give us summary. Summary also will give some statistical inputs about the data set. Okay. And then you set up the hypothesis testing. What is your null hypothesis? What is alternate hypothesis? Then get the Z values. Okay, not Z values, T value. And from the T value, you tell me whether your null hypothesis is accepted or not. Okay, if it is not accepted, what action you are going to take on the alternate hypothesis. So somebody have done it? Then I can see and then we can go forward.
Actually, I did the box plot for books to date and doing it online. I got a summary for both. I'm not sure how to check for normality exactly.
If it is looking like a normal distributed, then that's fair enough. For normal distributed,
So,
you will be finding plot the data and show me. No, can you share your screen? I'll put you as a presenter.
okay, let me plotting as a box plot. Let me just plot as Instagram and I'll share my screen.
So I put it as a presenter. So share your screen.
So, should I plot as Instagram?
Okay, bookstore data. Okay, so what is it you are plotting it here? Summary, box plot of price.
This is just a reference which I used.
Now you're plotting the diff, right? The difference of the means. Difference of the book prices. That is what it is, right?
Lakshmi, your voice is breaking.
No, what I'm saying is we wanted to see the difference of the book prices could be could be following normally distributed. So you just take the diff of the prices and then plot it using the box plot and histogram and see how they look like.
Okay, so we need to find a difference first. Okay.
Yeah, that is because of that I have given it, not individuals.
Okay.
to ensure that the data what we have collected, it's randomized, right?
Okay.
So you are working on getting the diff, and you can do it here on the R Studio itself. Right.
Yeah, I got the difference here. Can you see that?
Yeah, I think 16, no? Okay.
Darshan, yeah. So it's a vector here called
Yeah.
difference. It has a difference here.
Yeah.
Okay.
So it plots
So I'm just
not. Yeah, diff is you got the diff, then you box plot is fine. Box plot give the diff. Is it only diff is sufficient? Yeah. Okay. Now plot the histogram. What the hist?
still now for Instagram.
Yeah. Okay, so can I reduce the beam?
Pardon, Darshan?
Beams are little bigger. The histogram beams are very bigger. If you reduce that to something like a 10 or something, in size.
The width is same.
See, you can see, right? I mean, okay, the beam size you have to increase. It is taking minus 50 to 0, 0 to 50, 50 to 100, and 100 to 150, right? So
Yeah.
the beam size is yes, 50. So the beam size if you reduce to 10 instead of 50, you will look like you will find look like the continuous distribution. Okay, so you can see it is not that much pure data. Okay, it has variations and it looks like a symmetric distribution. Okay, So what we can say is, okay, this the sample which we have collected, it is not a biased sample. It looks like a randomized sample.
Okay.
I have to call the function. Okay. So what we can do is we can apply. Yeah. So,
I
so
could
you
figure
can.
out how to reduce the column width exactly, which property it is I'm trying to figure out.
Single number giving the number of cells, okay, etc. Check that. Google it. How to set the bin size in this function. Okay. You find. Okay. So that's okay. That's okay.
Is it okay? Can we continue? Do you want me to check?
Right, right. You can see this now. Now you put the hypothesis testing, what is null hypothesis, alternate hypothesis, and get the Z value. Okay, and get the Z critical value for what is it, 97.5 or 0.025. Okay, and then tell me what we need to do, whether we need to reject our null hypothesis or we have to stay with our null hypothesis. That's how
Z
we
or
can.
Z or T critical value? T, right?
You have to get the T critical value, right? Isn't it? You have to get the QT. QT for your, what is the sample size?
16.
This was
Sample size
15.
is 16, so n minus 1 will be 15.
And probability is 97.5.
Yeah.
QT 97.5, and this is the freedom 15, and get the value, this is critical value.
So one side test, right? One tail test.
975, isn't it?
Yeah.
How much you are getting?
I got 2.13.
2.13.
Yeah.
2.13. Okay, fine.
So
Then
next we need to.
now you get the P value from our sample data. What are you trying to do?
Just trying to find a formula.
Yeah.
So difference of the mean, yeah, average of the mean and
Trying to get the mean zero. Okay.
yeah.
Right. Now the mean zero is what?
Actually, voice is breaking.
What will be my mean zero?
population mean trying to figure out the population mean.
This is what, right? Uh, sample meaning minus mu of pt. What is mu of t here?
Mu I'm figuring out.
Zero, right? This is what we are assuming. Isn't it?
Pardon?
Mu of t will be zero.
Mu is 0.
Mu is zero, isn't it? This is what we are saying, right? Mu1 minus mu is zero. Means in my sample distribution, there is no difference.
Okay, okay.
Got it or not?
Yeah, so it's mu is 0, right?
No, you got it now. Why is mu equal to zero?
Because the sample population mean of both population is various.
This is my null hypothesis, right? In this null hypothesis, I say that mu1 minus mu2 is zero. Okay, so it means
Okay.
in my position where I have taken the sampling distribution is nothing but
Correct, correct. According to null hypothesis, there is no savings, so both the population means are same for online bookstore and normal traditional bookstore. Since their saving is equal, it should be mu1 and mu0 is equal to 0. Understood.
yeah, so the difference of mu will be zero. Okay,
Huh.
so it's p bar divided over nt root over. So you put this one and then get the PD.
3.78. So we have to reach the critical region.
So what the mean how the mean is higher than your T critical.
Yeah, so T critical is 2.13. So and the calculated T value is 3.78. So we have to reject the null hypothesis.
Right. So it says that, what? Online store values are much more, what is it?
Saving is more in online.
So more compared to online store.
Correct. In online.
This is what, this is how we can take the statistical, from the sampling data, we can take some sort of statistical distribution. Okay. And this is nothing but so this is where the data is coming from the same distribution.
Okay.
So if you come across in a retail market or something like a pharma domain, okay, and the initial setup you have to do is to set up the hypothesis testing. From the hypothesis testing only, you can take a next level of investigation. Some people skip this hypothesis testing, but it is highly recommended to ensure that your hypothesis testing is, what it is giving you a direction for next level of analysis. Okay. So yeah, today let me do one thing because it's already 9 o'clock. We can complete the class. We can end the class with paid test. What I can do is we can have one more online session where I will give you the no, I will have a talk about F test and then chi-square test. Okay, with that, our hypothesis testing will be done, and then we can go for the ANOVA modeling. Okay, so what
Okay, Lakshmi.
F so you guys can go through some of the videos or study materials. F test says uh, it is like the measure of no variations between two populations. Okay, so let's say consider that the means are same. Okay, but the variation in these populations are different. Okay, we have understood that any population, I mean, when we try to compare between one population to another population, we compare them with two parameters. What are the two parameters? One is mean, another is variance. Okay, suppose I found the means are same, it doesn't mean that both the populations are same, right? So what we need to do is we need to measure the variation. Okay, the measure of variation can be taken care by variance. So that's where I try to use F statistics, and F statistic is the building block for your analysis of variance. That is called ANOVA. Okay. Similarly, there is another concept is called chi-square test. Chi-square test is when your data is numerical data. Sorry, when your data is categorical data. Okay. So when you have two categories of fruit data, and now between two categorical data sets, you want to set up a hypothesis testing, then you will go for the chi-square test. So you guys just Google it and try to understand what is chi-square test and where I'm going to use it. Similarly, what is F test? What is the importance of F test? And then what I'm going to do is next class I will discuss both of them, and then I'll take up some of the assignments like the way we have done it today. Okay. And then I will release your hypothesis testing test cases, which you can start working on it. Even if no, the examples which I have said before, those questions you will able to interpret and you will able to uh, solve it. Okay. Yeah.
Okay,
And
Lakshmi.
if you guys have already book, I mean you can refer to the page number 350. Sorry, 352. Okay. This is the problem section for today's class. Okay. So there are 10, I think 4 or 5 problems are there. You can solve all of them. I don't think you will find any difference, any difficulties. If you find any difficulties, please let me know.
Sure, Lakshmi.
Okay, I think I can log up now.